Today I'm going to be showing you how to create a smart contract. But before I do that, I would love to go through the Solidity syntax. So you need to know how to create smart contracts, and for you to do that, you have to learn the Solidity syntax. So Solidity is a programming language similar to JavaScript that is used to write smart contracts. So for this tutorial, we'll be using the Remix IDE. We're using the Remix IDE. So to follow along, open the Remix IDE. So you can go to this URL here. Okay, I'm trying to. Okay, so you just type Remix IDE in your browser and click on this, and the Remix IDE will be opened. Yeah, so this is what we are going to be using to write our smart contracts today. So also, I would like to point out that our smart contract and Solidity will be written in a file with the .sol extension. Okay, that won't work. With the .sol extension. So here is a default Solidity file that has been written, but we're not going to be working with this, so you can just delete this. But this is the file we're going to be using. So yeah, so without further ado, I'd like to move forward and show you the agenda for this tutorial. So I'm going to start with the Solidity files. I'll go through the structure of a contract, data types in Solidity, storage and memory data allocations, literals, integers, Boolean, the bytes data, the arrays, structure of an array, enumeration, address, and mappings. So what is Solidity and what tool? Like I mentioned earlier, you were using the Remix IDE, and yeah. So let's quickly see the constructs that are available in Solidity. So a Solidity file is composed of 4 high-level constructs, as you can see on the screen. You have the pragma, comments, imports, contract, or library, or interface. So, okay, I'd like to explain each of this and show you or do a quick demo on how each of them are actually defined. So we have starting with pragma. So Solidity comes with its own compiler. When writing your Solidity code, you can define the version of the compiler that will be used for your code. So pragma is a directive that's used to specify this version of compiler, which is usually the first line of code. So I'd like to show you how this is done in the Remix IDE. So yeah, it's usually like this. It usually starts with the pragma keyword and Solidity with a capital letter S, and we have Solidity, and then you have this caret, and then this version number. Yeah, sorry. Yeah, so I would like to explain what this stands for. So the caret stands for the latest version, and 4 is the major build number, and 19 is the minor build number. Moving forward, I'd like to show you the next construct, which is the comments. So for the comments, it's very easy, just like any other programming language. It's actually very easy. So for instance, to decide to comment out this line, you just use for a single line, use the 2 backslash, or is that forward slash? That's forward slash, I guess. So you can use the 2 forward slash for a single line comment. Then for multi-line comment, imagine if you have you want to comment out a number of lines, you use this. So this is what you use for the multi-line comment. So okay, so moving forward, let's see the import construct. So When it comes to modularity in code, with modularity in programming, if you're familiar with other programming languages, you know that when you're working on a project or you're building an application, you'd tend to divide your project into several files, which you call modules, where each file is doing a particular thing, and it contains code. So in a situation where you want to use a code or embed a code from another file in your present working space or in the present file you're working on, you would have to, it's called modularity, because you're basically, that's what it's called actually. So if you want to perform modularity in Solidity, you can use the import statement. So the import statement is available for you to use. So it allows you to import other Solidity files to gain access to their code. So how does it work? You start with the import keyword, and then you define the file name. The file usually defined as a path. So the Solidity file that you want to include in your present Solidity file. So moving forward, the last construct, which is contracts, library, and interface. So let me show you how that is done. So it is possible for you to declare multiple contracts, multiple libraries, and interfaces within a file. So this is how it's done. How do you define multiple contracts within a file? So yeah, it's done like this: contracts, the contract keyword, then the name of the contract. In this case, I'm calling this second contract. Yeah, so I'm calling this second contract, sorry, that's an error. So this has defined. So you can have multiple contracts, like I said earlier, you can have multiple contracts, okay? So let's call this third contract or something, third contract or something. Within here you have your code. Then for libraries rather, to define a library in Solidity, you use the library keyword with the name of the library. Here I'm calling this, I'm naming this the math library. And you could also have multiple libraries. And then to define an interface in Solidity, use the interface keyword and followed by the name of the interface like this. So this is how it's done. Okay, so let me show you other things without wasting much time. Okay. Yeah. So let's look at the structure of a contract. So smart contracts are composed of state variables, structure definitions known as structs, modifier definitions, event declarations, enumeration definitions, and function definitions. I'm going to go through each of them. So starting with state variables. So in state variables are variables declared in a contract that are not within any functions. So any variable you define in your contract that is not within any function is defined as a state variable. So they basically represent storage locations, like the name variable implies. I mean, in other programming languages, that is what variables are used for. They represent storage locations that store current values that can be changed during runtime and are permanently stored in the blockchain. So these state variables are permanently stored in the blockchain and they can be changed during runtime. Now, while defining a state variable, you must define its data type along with it. So on the screen, you can see I mentioned a couple of data types: bool, unsigned integer, that is uint. Int stands for integer, byte, address, mapping, enum, struct, bytes, and string. Enum stands for the enum you see on my screen or on your screen stands for enumeration, and then struct stands for structure. So so while defining a state variable, you must define a data type which would enable the Solidity compiler to determine the size of memory that should be allocated to the variable and also know the values that can be stored in them. So that is why you must define a data type alongside the state variables anytime you're defining in a contract, because that will actually tell the compiler that this you should use a certain you should allocate a certain memory size to this variable, And also, these are the kind of values that this variable accepts. That is what, so you have to inform the compiler by doing that. So let's look at an example. So back to your Remix IDE. For example, a state variable you can have a state variable of unsigned integer 8. This data type will have an allocated memory size that can contain values between 0 to 255. Now, that's what I'm actually talking about. Okay, so also there are qualifiers that are associated with state variables that determine the accessibility of your state variables. Now, when you define the state variables in your contract, these qualifiers that I mentioned on your screen, internal, private, public, and constant, actually, when you use them with the state variables, they determine the visibility of the state variables. Okay, so you see, moving forward, let's see. Okay. Oh, what's going on? Okay, so let's see what this internal qualifier does. So it comes by default. This internal qualifier comes by default with the state variable. So if no qualifier is defined, automatically the internal qualifier will be used. So this qualifier makes your variable only accessible within the contract functions and derived function contracts. So anytime you use the internal qualifier, or when you do not define any qualifiers, by default, your state variables are set to are going to use the internal qualifier. So what that does, or what that means, is that your variable is only going to be accessible within the function in your contract that it was defined in, and also be accessible by functions that were derived from that particular function. So private qualifier is a qualifier that makes your variable only accessible within the contract function. So it's like almost like the internal qualifier, but it is only the variable can only be accessible within the contract functions and not by any other derived functions. Okay, so the public qualifier, with this qualifier, your state variables can be accessed directly via a function that is generated by Solidity called the getter function. So here, if you use the public qualifier, your state variables will be accessed directly outside of your function. Okay, so it's like the opposite of the internal function, opposite of private qualifier rather. So the constant qualifier, with this qualifier, the state variables cannot be changed, and you must assign the variable at declaration time. And okay, so I'm going to show you how the syntax for the internal qualifier. So let me show you the syntax for the internal qualifier. So for the internal qualifier, it's simple. So like I mentioned earlier, when defining a state variable, you must define the data type. So the data type here is integer, and then you're defining this state variable, the qualifier called internal, and then the name of the state variable here is state variable. So that is for the internal qualifier. That's for the internal qualifier. Now for the private qualifier, here we're also using a data type of integer, and you're setting the qualifier to private, and then the name of the variable is private. It could mean this small letter s. So private state variable, for example's sake. So this is the private qualifier. Okay. So you also have the public qualifier, and is defined as thus. Okay, so this is the name of the variable, and this is the public qualifier. So you also have the constant qualifier, and here I'm using the bool data type, and then I'm setting it with the constant qualifier, and then the name of the constant here has income, and I'm setting it to true. Now I'm showing you that, like what I said earlier, I said for the constant qualifier, the state variables cannot be changed. When you use the constant qualifier, you cannot change the state variable. Okay, you can't use it. You can't change the state variable. Okay, and you also assign the variable at declaration time. So here you're assigning it to true. Okay, so moving forward, the next one is the structure definitions. Okay, this is a typo, you can just correct it, it should be I. Yeah, so structure definitions, a structure can also be called struct, and it is simply a data type that consists of multiple data types. They are defined like contracts, but they do not contain code. Now, so when do you use them? When do you use structure? When do you define structures rather? So anytime you have to store multiple data that are related to each other. For instance, you want to store an information about a student like their names, ages, origin, and status. You can use the struct to define them. Let me show you how you can do that in your Remix editor. Here, I'm just leaving here. So moving forward. So for the structure definitions, structure definitions. Yeah. Okay. So you're defining your structure with the struct keyword. So you use the struct keyword and then the name followed by the name of the structure. In this case, I'm using my struct and then curly open and closing curly brackets. And then inside of here, you're going to define your related information. Now they are all variables, yeah? So you have to define them with the data type. And here I'm defining the name as a string. I'm defining the age variable as an unsigned integer, which is I'm basically saying this age variable cannot accept any value aside positive values, cannot accept negative value. That is the meaning of unsigned integer, in case you're wondering. So you also have the variable of status, yeah, the bool data type, which can only accept values of true or false. That is what this bool data type stands for. And then you have the last variable set to origin. So this is how you define the structure in Solidity. Now, moving forward, how do you use this structure? You have to create an instance. And how do you create an instance? So let's create an instance. So let's create an instance. So to create an instance, all you have to do is assign the instance to a name. Now I'm calling it student, okay? And you call the structure with the name of the structure, and then you pass in the values according to the variables that were defined. And the first one is defined as a string, so it has to be a string. So here I'm just calling it my name, Deborah. And yeah, unsigned integer must be 20, must be a positive number, so I'm using 20. The status, true. The origin, Nigeria, has to be a string, so it has to be between curly braces. Okay, sorry, between quotation marks. That was an error. Okay, yeah, so let's move forward to modifier definitions. So modifiers are used to change the behavior of a function. They are declared in the functions, so they are basically executed before the function itself. Now, when do you use modifiers? So there may be times where you have written a function that you would like to execute, but before the function executes, you would want to check the information that may be passed as parameters to the function to validate them if they are true or if they are rendering what is expected before running the function. Okay, let me give you an instance that will probably make more sense or be clearer. Okay, so for instance, you have let me use the same student example. You're trying to acquire information from students about students in this particular school, and then it's information like their name, their age, their department, their courses, and all of that. And you create a function, you write a function in your contract that is probably that has parameters that are defined in the function that are getting the name of student, the age, the class, the course, whatever, the department of the student, and basically information about that particular student. Now, you may want to validate if the data that is being provided by the student, like the information that is being provided by the student. Maybe you want to check and ensure that their names must be a particular length. It must be 10 words, or you may want to validate that their age is between from 18 and above. Stuff like that. You would use a modifier. And as I mentioned earlier, the modifier is going to be called inside the function, but it will be defined as a global. It will be defined as a global function, but then it will be called inside of the function. Don't worry, you get to understand what I'm saying when we start practicing. So how do you define a modifier? How do you define a modifier in Solidity? So how do you define modifier? How do you define modifier in Solidity? Simple. You use the modifier. Notice the lowercase. It must be lowercase because Solidity is actually a case-sensitive language, so you have to stick to the syntax rules. So here we have the modifier keyword, and then the name of the modifier, which, like I said earlier, we accept parameters, and then the code to be executed will be within this block. I will not write much on this modifier block. I'll come back to it after I have explained function, giving you a demo on functions. So before that, I want to talk about events declaration. So just the way events work in other programming languages, which are used for notifying applications about changes made in the contract. So you declare events at the global level. When I mean global level, I mean outside of every function and at the top of your code, at a global level with an event keyword, with an identifier and parameters that are defined by data types. So I'm going to go into my IDE now, and I'm going to show you a demo on how you can define an event. So how you can define an event in Solidity. So yeah, you have event. Okay, event, which is the keyword. Start with the event, the keyword event, and then the name of the event. In this case, I'm using my event. Okay, my event, and then this event, I'm passing parameters as data types. So I have integer and I have a data type of address. Simple. So yeah, so these events are invoked in functions when they are called. So moving forward, let's see enumeration definition, how to define enumeration. So enumeration is used to define a set of named constants with an enum keyword, and each of the constant value is assigned an integer value of 0 to 1, and it does not end with a semicolon. So enumeration is used when you have a constant list of items that do not change. When do you use enumeration? When do you define an enumeration in Solidity? When you have a constant list of items that do not change, that is when you use them. So how do you define enumeration? So I'm going to show you how to do that. So I'm sorry for enumeration. Yeah. So you use the enum keyword followed by the name. Here I'm calling it sex, or you can call it gender, whatever. Okay, and then you have within curly braces you define your constant list of items that do not change, and here I'm using male and female. So how do you assign a value to this enumeration? So let's see how you can assign. So assigning values. Okay, so we have gender. So you would use the name of the enumeration, which is gender here, and then underscore gender equal to, now you use the gender enumeration name, and then you use dot female, and then the value will set to gender. So that's how you basically assign values. So for functions, yeah, so functions are very key in smart contracts. I mean, you create transactions with functions. You create transactions with functions. So it's when functions are invoked that transactions are created, basically. So functions are a unit of code that accept parameters and execute define logic and return values. So let's see how you can declare a function in before I show you how you can declare a function in Solidity, I would love to also explain, point out to you that the definition of parameters are optional, but you must provide a data type if they are defined. And I would also like to point out to you the function qualifiers. Before I do that, let me show you how you can declare a function. Okay, so let's go into our IDE. So moving into so moving to the IDE here, you have function declaration, and then let's define a function. So how do you declare a function in Solidity? You start with the function keyword, which is all lowercase, and then the name of the function. Here I'm calling it student info, and you have open and closing brackets. Then inside of this bracket and are where you pass in your parameters. So you have the address, and you have, now I'm calling this address because this is the data type I am using. So you have underscore, the name of the address. So the name of the address, which is this identifier, and this is the address they're using. Now this is a state variable. This is a state variable, and you have to define it here. And this, well, sorry, that was an error. Sorry, this is the parameter, and you're defining it with a data type. And then you have your code block where you have the code that will be executed. Now, I mentioned earlier about modifiers. I talked about modifiers earlier, and I'm going to show you in detail soon how you can use modifiers in your function. Before I do that, I'll just put in a random modifier that will probably create later called validate. So this is a modifier, and then there is a modifier that comes with Solidity that tells this function that it's payable and stuff like that, that it can accept payments and stuff like that, and ether. So also have external here. I'm going to be explaining in a few seconds or a few minutes what this means or what this stands for. Then we have the returns keyword. Now this returns keyword is used whenever you are returning something from a function. So there are functions that you do not return anything from, but in this sense, now you may be using a function that returns a value, so you have to use the returns keyword. And then when you are returning a value from a function, you must define the data type of that function that you are returning. And in this case here, I'm returning, let's say I'm returning, for this instance, I'm returning a value of type unsigned integer. It could be string, it could be whatever, it could be any data type. Basically just defining the type of the value you are returning. So you must define it here when you are defining functions or declaring functions in Solidity. Now let's define this modifier here. So like I mentioned earlier, you must use the modifier keyword and then the validate, which is the name of the modifier we're using here. And then this, what it does is basically it checks if the address of the caller will invoke the function using a global variable called message sender. I will explain that soon. It checks if the address of the caller who invoked the function, it checks if it is equal to the identifier of the student that is passed in as a parameter in the function. So we have student identifier here. That's basically what it does. So after it does that, after it checks for that information, then it's going to execute the target function. How? With this underscore. By just saying underscore and that's it, it executes the target function, which is this function that it was used on. Simple. So yeah, so let me just do a recap. So this modifier is checking the value of the incoming address using the msg.sender, and this address is stored in the student identifier state variable that was declared in the function. So in Solidity, you have message and global variables. In Solidity, you have I don't know if I pointed that out. Okay, no. So in Solidity, you have a message and global variables such as let me just type it out here. So msg the sender, which is the address of the caller who invokes the function. You have the msg dot value, which is now this msg dot sender accepts state variables of address type. If you notice here, we used a state variable of address. So yeah, it accepts a state variable of address. And then we have the message.value, which this global variable is for the amount of way, used to check the amount of way sent along with a transaction. So when you want to know the amount of way sent along with the transaction, you can use this message.value, and it accepts a type of unsigned integer. And then you have block dot difficulty, and this accepts a type of unsigned integer, and basically stands for the difficulty level of a currently block. So it's used to determine the difficulty level of a current block. And then you also have one like block dot gas limit, and this accepts the data type of uint, and it's a gas limit for, it's used to check or determine the gas limit for a current block. And we also have the block dot number. We also have the block dot number. Okay, and this accepts a type of unsigned integer, and the block number in sequence in sequence the block the timestamp. Okay. So sorry, this block number stands for the number of the block, yeah, and it returns the number of the block rather. And then we have block the timestamp, have numbered block the timestamp, and it has accepts a state variable of unsigned integer type, and this is basically determines the time that the block was created. So these are just a few of the global variables that are present in Solidity. You could always do a Google research and search all the global variables that are actually available for you. So moving forward, let us see. Let's look at function qualifiers. So remember I mentioned earlier that qualifiers were used with state variables. Now you can also use qualifiers with functions. So these qualifiers determine the visibility and accessibility of a function. And some of I think the major qualifiers I have come across so far in Solidity for function that can be used with functions are the public, internal, private, external, constant, view, pure, and then the payable, which is like the one that comes by default with Solidity. Yeah. So let me explain each of this if I move forward. So the public qualifier are used for functions that you want to be made publicly accessible, while internal, by default, the state variable has an internal qualifier, and if nothing specified, it means that I should say function. Yeah. So by default, the function has the internal qualifier like the state variables, and if nothing is specified, it means that this function can only be used within the current contract and any contract that inherits from it. or any derived contract. So these functions cannot be accessed from outside and they are not part of the contract interface. Then we have the private qualifier, which are used for functions that you want to only be accessible within a contract. So private functions can only be used in contracts that are declaring them, and they cannot be used even within derived contracts. They are not part of the contract interface. Then we have the external qualifier, and this visibility makes function accessible directly from outside functions can actually access any function that you define as an external function, with the external qualifier. And for the constant, so you use the constant qualifier for functions that do not have the ability to modify the state of the blockchain. So when you do, I'll show you how to do that and how that works soon when we start the demo, when we start creating or writing our sample smart contract. Okay, so so these constant these functions that use the constant qualifier can read the state variables and return it back to the caller, but they cannot modify any variable, invoke an event, create another contract, or call other functions that can change state. And so you can think of constant functions as functions that can read and return current state variable values. Then we also have the view qualifier, and these functions are aliases of constant functions. And then we have the pure qualifier. Pure functions further constrains the ability of pure functions. So pure functions can neither read and write. In short, they cannot access state variables. Okay, and then functions that are declared with this qualifier should ensure that they will not access the current state and transaction variables. Then we have the payable qualifier, and functions declared with the payable keyword has the ability to accept ether from the caller. The call will fail in payable case if ether is not provided by the sender. The call will fail. So a function can only accept ether if it is marked as payable. Okay, so let's quickly move forward and see how we can define arrays and also the structure of arrays in Solidity. So like other programming languages, in Solidity you can also define arrays. So arrays are simply groups of values that are of the same type, and in Solidity arrays can be fixed or dynamic. So we have fixed arrays, we have dynamic arrays, we also have special arrays which include byte arrays and string arrays, but I will not be covering them in this course. So for the fixed arrays, you can declare an array and at the same time define its size. So let me show you how that is done for the fixed array. So let me show you how you can define a fixed array. So here we're going to declare an array and at the same time define the size of the array. So how is that done? So here we have an array of integer type, and then we are specifying that this array is of size 5. It can only contain 5 values. So it's basically an array of ints, and then before I continue my explanation, I'd like to also point out to you that this array has to be given a name. So once you define the size, the data type, the size, you define the name of the array. So basically what I'm saying here is this is an array of integer with 5 fixed storage space allocated. So this array has a 5 fixed storage space allocated. Okay, 5 fixed storage space allocated. Simple. So then you could also have an array of different types. You can have an array of bytes. Like I mentioned earlier, we have special arrays in Solidity, byte, and then here. So I wouldn't really cover that for now. So let me just show you how you can initialize an array. So how can you initialize an array? I mean, you just define the array here. So how do you initialize an array? Simple. You can also initialize an array inline. How? By what you use to define the array, using what you use to define the array, then using the equality sign, and then here notice that we are using a square bracket. Notice we are using a square bracket, and then inside of the square bracket we use the same data type we use to declare the array, and then we have the first value, and then the rest will be defined as thus. Yeah. Notice it's 1, 2, 3, 4, 5. Okay, which is the 5 storage space allocated to this particular array of integers. And notice that the array only accepts integer values because you used a type of integer. So that's basically what it is. So you can also declare the array and assign it afterwards. So it's possible for you to declare the array and assign it, which is basically what it's possible for you to declare the array and assign it afterwards. So here we have the array declared, and then we can come and assign it here by just saying age equal to and this here. Okay. And also notice that for every line of code in Solidity minus 0 enumeration, you have to end it with a semicolon. Now, we also have dynamic arrays. So we also have dynamic arrays. That's all for fixed arrays for now. So dynamic arrays, the size of the array can be determined at runtime. So it is the opposite of the fixed arrays, where you do not define the size of the array on declaration of the array. It is the size of the array is actually determined by Solidity or by the compiler, because Solidity comes with its own compiler. So this is determined by the compiler during runtime. So you do not define the size at declaration. And let's see how you can declare a dynamic array. So let's see that. So dynamic array. So yeah. Okay. So you have ints and age. Yeah. So this is an array of ints with no fixed storage space allocated, and storage is allocated during assignment. Simple. Now you can use the new keyword. Now let's see how you can initialize a dynamic array. So initializing a dynamic array, you can actually oh my god, talking and typing is so stressful. So initializing an array, or dynamic array rather, you can use a new keyword. So Solidity provides you with a new keyword to initialize the dynamic array, but you can't do that for a fixed array. So how does that work? So you can initialize it at the time of declaration, and which is so you can initialize your array if it's a dynamic array at the time of declaration, like the fixed array. So just copy this and paste, so I spend less time typing. So yeah. So and then you can use the new keyword to initialize the array as well with a dynamic array. So we have the new keyword here, then we have int, and then we have 5. Notice it's within brackets. So that's basically it. So that's how you can declare and initialize a dynamic array. So moving forward, let's see constructors. So constructors are the first set of codes that are executed once while deploying a contract, and they can accept parameters. So when defining the constructor, it must be the same name as the contract, and qualifiers can also be used with constructors to determine their visibility, but they are restricted to only using public or internal qualifiers. So the constructor does not return any data. Now let's see how that is done. So yeah, let's see how that is done. So yeah, we have the constructors. So yeah, so we have the constructors. So we have it here. So yeah, let me create a contract. So I'm going to show you how this is done later, but then this is how you create a contract. This is how you create a contract with the contract keyword, and then the name of the contract. In this case, I am using sample, and within this, I am declaring a state variable with a private qualifier name, which means this state variable can only be accessible within this contract that it is defined, and not by any other contract defined outside of this. Because you can define multiple contracts. So if you have another contract that is defined here, let's say another contract defined here, this name state variable will not be accessible here in this second contract. So yeah, so here let me show you. We have a function. We have a function sample called sample, and this function is a public function, meaning it can be accessible outside or within this contract, and also outside this contract by derived. Basically, it can be accessible by contracts that are derived from this particular contract, from it itself. Yeah. So, here we have we're setting the state variable we defined here. We're setting it to a string of Debbie because that's the type we gave it. We assigned the state variable. Yeah. So here we are creating now we are creating a another function that gets the name that was set. Now so this function has a public qualifier as well, and then sets view, and then returns a value of type unsigned integer, and it returns the name state variable that was defined here. So then you have another function called set value that would set the value of the name, and this accepts a state variable of value, and it's also public. Yeah, it's public. And then we have within the function basically sets the state variable, which is name, and then sets it to the value that the parameter that this set value function accepts. So yeah, moving forward, I'm showing you how you can define constructors. Yeah, so this is a constructor here. If you notice, this constructor has the same name as the contract, like I mentioned earlier, and it does not return any values. Basically just setting the state variable here to Debbie, which is name. Yeah, so I think I have okay, so let's go into practice and start writing our smart contracts. With this information I've covered so far, you can actually start writing your smart contract. So let's do that. Let's get right into it. So in your Remit editor you have opened, you're going to start by like I mentioned earlier, the first line of code is going to be your pragma. Yeah, that is setting the solidity. The solidity to a version. Now, how do you know the version is set to solidity? It's simple. I think you have to come here, and here you can see the latest version. You can use this 0.8, 0.8.12 as your compiler version for your Solidity. And then let's create a contract. So you start by using your contract keyword. Okay, so you create a contract with the contract keyword, and then name of the contract. It has to start with a capital letter, so that's why I'm using the P here. We're calling this contract program. Yeah, so here we're going to define two state variables of string data type, and we're going to set them to be publicly accessible, and I'm calling this Zurich student jury student, I'm calling this other one tag, and I'm setting it to a string, welcome. Okay, and then within this contract, we're going to define a constructor. So I'm going to just give it the name, constructor. Yeah, we're going to define a constructor. Sorry, we're going to define a constructor, and this constructor is going to accept a state variable of called student name, and then we're going to set this constructor data location to memory. I'm going to explain why I did that now. Okay, so why did I specify the data location for this variable that was set in the constructor? I did that because when you are writing smart contracts in Solidity, by default, any state variable you define globally here is going to have by default a storage. It's going to have a storage data. It's going to be saved in storage data location rather in the blockchain. Yeah. So now here, whenever you're using a variable within any like a constructor or a function, you have to explicitly define the data location. And here we want this. You can either specify the data location to be saved to storage or memory or call data. I'm using memory data location because I want this to be temporarily stored. Okay, so that's why I'm using the memory data location. So moving forward within our constructor, we basically want to set our Zuri student state variable. Basically want to set it to the student name variable here that is passed in as a parameter to the constructor. That's what we're doing for the constructor. And then remember, I don't know if I mentioned it, but if I did, it's fine. I'll mention it again. So remember that anytime a contract is invoked, anytime a contract is called, anytime it is called, the first thing that executes is your constructor. That is the first thing that executes. Okay, so this is the first thing that is going to execute our constructor when we run this contract. So moving forward, we're going to define several functions, starting with a function called create record. Okay, and then we're going to define this function is going to accept a parameter of type string, and is going to be saved to memory data location, and the name of this. So we have the public. We set the public qualifier on the function, and now within this function, we basically want to set the Zuri student to the new record. So the next thing to do, we're going to declare another function called get record that would get our record, and with a public qualifier and view qualifier, and then returns, and then string, then string. So it's going to return a value of type string and saved in the memory, and then so view basically means that the function does not change any data on the blockchain. And then basically what this function does is it returns, okay, so we want to concatenate this string, and then Solidity provides a method you can use called abi.encode packed. So within this, we're going to pass in what we want to encode, which are the two state variables, tag and then Zuri students, and then we have to calculate this within a string. So this, we are basically doing type conversion here, although it's already in a string format, but I'm just showing you how type conversion is done in Solidity. So yeah, so that is done, and yeah, right. So I'm going to also declare another function. I'm going to declare another function. So this, just a quick recap. So this function creates a record. This function gets the record. Yeah. So that's basically it. So yeah. So I think that's fine. I think we don't have to create another function. I think that's fine. So how do we run this? Okay. Now you see on this side of the code editor of the Remix IDE, you can see it's like giving you a warning saying SPDX license identifier not provided in source file. Before publishing, consider adding a comment containing SPDX license license identifier to each source file. Okay, so basically what you're going to do is you're going to add a license MIT license identifier to this source file, which is good practice, and that is why this highlighted for you to do. So basically you can do that with comments by saying SPDX license identifier and MIT. So here we're using the MIT license identifier. Now, how do you compile this? You compile this Solidity file by clicking on this whatever it's called here, and then you click on this compile. Yeah. Then once you do that, you can come here, click on this, and then once it's compiled, yeah, once you click here, it's going to compile. And then when you click here, you go to deploy this this smart contract by clicking on this deploy button. So click on deploy, then you have this displayed in terminal. Here you have this displayed in the terminal here with this green tick showing that it has been successfully deployed. So now you can view what was deployed, your smart contract, and then run it here, like test it if it's actually working here. So here you can see the state variable that Solidity created a getter function immediately you declared your state variable here. 0 students, you can see tag here, which is your second state variable, and then you have the get record function. I have the create record function. So here, if you click on 0 student, you see that it gives you string, and then the tag gives you a string of welcome, which is actually the value here. You click on get record, you have it giving you welcome. Now for now, so now we want to test if our smart contract actually works. So here we can enter a new record. You can call it Deborah, yeah, and then click on create record, and then click on get record, and you have welcome Deborah, which is actually what is meant to be returned. So you see that your smart contract is actually working, and you've successfully created and deployed a smart contract using the Mix IDE editor. So here I've come to the end of this tutorial, and I hope it was worthwhile and you learned to love it. So bye.